In an aldol condensation reaction, the proton from an alpha carbon from an aldehyde ketone is removed to form an enolate ion. The nucleophilic enolate ion reacts at the carbonyl carbon of an aldehyde ketone to form an alpha beta unsaturated aldehyde ketone. So let's work backwards. Starting from the alpha beta unsaturated aldehyde, identify the aldehyde ketone to make that compound. So I hope you looked at this hint. Note that this is the bond that forms when the enolate ion reacts at the carbonyl carbon. The structure of the aldehyde is, note that the proton from this alpha carbon is removed, and that's going to react at this carbonyl carbon. Antitoxin is found in blue-green algae, and it's a VFDF, very fast death factor. Note that this compound is an alpha-beta unsaturated ketone, so do a retroaldol condensation and draw the structure of the products of this reaction. Note that this is the bond that forms in an aldol condensation, so the structure of the product is, note in an aldol condensation reaction, the proton from this alpha carbon is removed, and it'll react at this carbonyl carbon. Many of you are biology majors, so you're familiar with glycolysis, in which glucose is converted to pyruvate in 10 steps. The fourth step involves a retroaldol condensation, so stop the video and identify the enolate ion. So the proton on this alpha carbon is removed to form an enolate ion, which will then react at this carbonyl carbon to form this aldol product. So working backwards, note that this carbon-carbon bond is broken in the retroaldol condensation. A Claisen condensation involves an ester enolate ion. The ester enolate ion is a nucleophile, and that reacts at a carbonyl carbon in a nucleophilic acyl substitution reaction. Note that a tetrahedral intermediate forms. This group is going to be the leaving group, and that's going to form a beta ketoester. So let's practice. Given this ester, predict the product of the Claisen condensation reaction. So stop the video and draw the structure of the product. So remember that the proton on the alpha carbon is removed to form an ester enolate ion. The ester enolate ion reacts at the carbonyl carbon of an ester to form a tetrahedral intermediate. This group becomes the leaving group and forms a beta ketoester. So a good way to check your understanding is to work it forwards and backwards. So given this beta ketoester, determine the reactants to make this compound. Stop the video and draw the structures. So the bond that forms to make this beta ketoester is this one here. So here's the structure of the ester which makes that product. Let's review aldol and Claisen condensation reaction. So stop the video and answer these questions. So an aldol condensation involves an aldehyde or ketone, and a Claisen condensation involves an ester. In each reaction, the proton on the alpha carbon reacts with the base to form an enolate ion in the aldol condensation reaction and an ester enolate ion in the Claisen condensation reaction. So the enolate or ester enolate ion reacts at the carbonyl carbon to form a tetrahedral intermediate. So if the tetrahedral intermediate does not have a leaving group, nucleophilic addition occurs to form a beta hydroxyaldehyde or ketone, or alpha beta unsaturated aldehyde or ketone. So that's the aldol condensation reaction. If the tetrahedral intermediate has a leaving group, nucleophilic acyl substitution occurs to form a beta ketoester. So that's the Claisen condensation reaction. So remember, look for that leaving group in the tetrahedral intermediate.